Hey, what's up? This is Coach Hyde. My website, hydescience.org. A bunch of physical science videos on there for you, ready to go. Today we're going to be talking about mass versus weight. What's the difference and how to calculate? So mass, right? Mass is the amount of matter inside of something. So the amount of stuff. You can say we're talking about today. What are you made out of? What is this matter that's inside of you? Your bones, cells. You're mostly made of water, right? All these kind of things. Yeah, they're all matter. All this is matter. The most basic building blocks of matter, when we kind of think about what things are made out of, is the elements from the periodic table. Those become compounds or molecules, and it gets bigger and bigger and so forth. But this is matter. Right? This is what you're made of, no matter what. If I get in my truck, we're in Georgia now, and I drive the next county over, I still have the same mass. If I drive to Alabama, if I drive to Tennessee, I still have the same mass. Now it may differ a little bit based on maybe I ate a couple hamburgers on the way, so I got more matter inside of me. Maybe I cut my hair, but that's going to be such a small amount of mass loss. It wouldn't really even matter. Um, Maybe I'm burning fat, maybe I'm adding fat. So, my mass may change slightly based on the habits of my life. But, in terms of if I was to take off in a spaceship right now, I was to land on the moon 5 minutes from now, my mass would basically be exactly the same thing. Any change would be negligible. Now, weight is different. Weight depends on the gravity. So, as long as gravity stays constant, my weight's going to stay constant. Maybe I go up into high altitude areas where I'm further away from the earth, so gravity don't pull on me as strong. So I might weigh a little bit less on one of the mountains people climb. I'm having a blank right now. Um, Mount Kilimanjaro, maybe my cousin just went and climbed that one. Maybe she weighed a little bit less at the top than she does here on sea level. Or maybe you can be closer to the earth, down in a valley, real deep trench, maybe out in the ocean. Um, you may a little more because you're closer to the center of the earth. Gravity is stronger the bigger the object. So the bigger the object, the more mass the object has, the stronger the gravitational pull of that object is. The closer you are to that object, the stronger you can feel its gravitational pull. Now, solving for weight using this formula here. We got weight equals mass times gravity. So we said mass is always going to be the same, right? And weight is dependent on gravity. Well, the formula tells the same story. Weight equals the combination, right? The quotient of mass and gravity. So if you consider mass and gravity, that's going to give you your weight. If you're just talking about mass, right, you're just talking about mass. Don't really go with the formula. So what we're going to do here is just kind of show you how we work it. So weight is going to be in newtons. This is our unit for force. So any of our forces we do throughout the year, it's going to be reported in newtons. Mass, just like everything we do, mass is going to be grams. Gravity is acceleration of gravity. How fast do you accelerate towards the earth? How fast do you accelerate towards the object that is pulling you in? So it's going to be meters per second squared. We have a distance per second every second. You're increasing your speed, meters per second, every second. So that's acceleration. All right, so you just come plug this in. I weigh 300 pounds, a little bit shy. We'll just round up about 4 pounds. We'll say 300 pounds. So, and in the metric system, 300 pounds, that's going to be, I looked it up earlier, 136 kilograms, something like that. It's like 2.0 kilograms per every pound. So my mass is 136 kilograms. The gravity here on Earth is 9.8 meters per second squared. And I have a little, list up there of the different things. And we want to solve for the weight. So all you're going to do here, I'm grab my little trusty calculator right here. We're going to do the mass, 136, times acceleration of gravity, 9.8. And let's see, can you see that right there? That's fancy right there. All right, so it's going to give me 1,332.8. Now, none of our units cancel. Our units are, so we got weight equals 1,332.8 kilograms, meters, second squared. I thought you said that the unit was going to be newtons. Well, this is a newton. 1 kilogram per meter second squared is like we abbreviate it or we summarize it as a newton, any force. So we can replace kilogram meter second squared, which is right if you leave it like this. I mean, that's correct technically. We can replace that with the newtons. Now, if I was asking you about weight on anything else, these are different gravity constants from different planets or the moon. So you could just replace the gravity. So if we're talking about Earth, we use 9.8. If we were not talking about Earth, if we were talking about the moon, we would plug 1.62 meters per second squared in because that's the gravity we'd use because we're on that planet. If we're on Mars, we would use 3.7 meters per second squared because that's the acceleration of gravity from Mars. Jupiter, 23.1, so forth and so on. So just, depending on what planet you're talking about, depending on there's different gravities on Earth that they don't vary a whole lot. You might have 9.7 in one spot, maybe 9.89, 9.84 in different parts of the Earth. So you can change this up based off of a table or data. So again, your weight, we measure in newtons, just multiply the mass by acceleration of gravity. Remember, mass never changes, weight changes depending on gravity. That's it for us. Let me know if you have any more questions, mass versus weight, or physical science questions. See what I can work up. Visit hidescience.org for more videos and such.